So thank you for the interest. So today we're going to be talking about, pop back a slide. We're going to be talking about blockchain, and we're going to be talking about it at a high level. This is a class that I would like you to take away from it an interest in what the blockchain can do. So we're going to talk about the component pieces of what makes a blockchain. So our agenda this evening, quick introduction to what a blockchain is. Then we're going to move into how transactions actually occur on the blockchain. And then we're going to get into consensus, how the blockchain actually trusts the nodes. And then we're going to talk about cryptographic hashing. And at that point, we will have covered the foundational blocks of what makes a blockchain. And then the last two pieces are what I call programmable blockchain. And that gets us into smart contracts, tokens, and then the usages of blockchain outside of cryptocurrency. A couple of things we're not going to cover tonight because it gets really, really in depth. See if I don't kill myself on the drop cord. We're not going to get into a specific currency. There's a ton of coin out there. Their blockchains are implemented differently. There's a ton of tokens running on Ethereum. We're not going to get in depth into any specifics. The other thing we're not going to talk about are wallet types. We will talk about what a wallet does. But there are things out there like hard wallets, soft wallets, custodial wallets. We've got everything but leather wallets. So we will touch on the wallet. And then the other thing we're not going to get into because it's a part of the consensus method and it varies between blockchain implementations. And that's how transactions are actually validated to make sure that you're not spending an asset that you don't have. And just know that that's a thing when we start talking about writing transactions to a block, but we're not going to go into any depth into it. And then with that, we'll start the discussion of what a blockchain is. So in the simplest terms, the best way to think of a blockchain is as a ledger. What a blockchain does is it records transactions between parties. But unlike the old paper ledger, the blockchain is decentralized. So if you think about the ledger book, it is in somebody's hands, and we have to trust that person who is recording things into the blockchain or into the ledger. So our blockchain, our electronic blockchain, is a decentralized unit. It's out in the cloud so that everything is public and available. And it is tamper evident, meaning that we have the ability to trust the contents of what's in that ledger. Touch briefly on where the blockchain actually came from. The idea of an interconnected ledger has actually been around for a really long time. There are a couple of college papers from 1991 that talk about the concept of interconnected self-verifying ledger entries. But the whole idea gained prominence in 2008 when thank you, Satoshi Nakamoto actually presented an idea for a hash-based system for tracking records. To talk about Mr. Nakamoto, nobody actually knows who he is or whether he's an actual person, a group of people, or anything. He basically presented his ideas out to the world and has since disappeared. And there's no real reason for why he did that, if it is, you know, one person. So that's where we started at. So let's talk about why it's called a blockchain. So if we think about our ledger, we're writing our debits and credits into it. So what the block is a group of those transactions that are together as a unit. And then we're going to write that unit into the blockchain. So you're going to hear me talk about the term hash throughout this. And we will eventually get to a final definition of what a hash is. But right now, what we want to think of the hash is it is some function that we can pour a variable amount of data into. And we will get a unique variable back out of that is always of a fixed width that uniquely identifies that data that we put in. So when we put the same input in, we'll always get the same output. So once the hash is created that identifies the data that's in that block, and the block has been verified, that block is then written to the blockchain. And what we do is we take the hash off of that block, and then we append it to the next block to be written. So that gives us our concept of a chain. So with the introduction of tokens and smart contracts, and being able to store more than just transaction data out on the blockchain, we're actually moving toward a world where we have a verifiable distributed database, because we can take our smart contracts and we can store any data with it. So that's where we're headed. So one of the big terms that you hear about when you hear about blockchain is decentralization. And all decentralization is we're transferring control from one body to a group. And in the blockchain, when we talk about decentralization, we're talking about stakeholder devices or nodes. These are our miners out there. They're responsible for maintaining our ledger across multiple machines. So what are the benefits of this decentralization? Well, one thing, I don't have to trust you anymore if you tell me something's in the ledger, because everybody has a copy of the ledger. I can actually go look at my copy and say, yeah, well, this doesn't match what you're telling me. The other thing with decentralization, because everybody has a copy and we're spread out across multiple nodes, we gain resiliency. So a few nodes or a group of nodes failing does not cause the blockchain to go down. And then the last thing is consensus. We have to have a method for trusting each other. So consensus is when a stakeholder presents a block to the network, and if that block has been tampered with, it's verified against the other nodes. And if a majority of nodes say the block that you've presented is invalid, then that block is rejected. So I'm going to take a second here and ask if there's any questions about just the blockchain in general before we get into transactions. So we're going to talk about transactions and wallets now. So how do transactions occur? A transaction is a transfer of information between two digital wallets. And in this case, a wallet is really a misnomer. You think of a wallet as something you put stuff in, you put your money in, and you put your credit cards in it. The wallet in this case is our gateway onto the blockchain, and it really only contains two pieces of data. One is our public key and our private key. So let's say I wanted to do a transfer of 10 ETH to Austin back there, he's playing on his phone. So what we, yeah, I figured notes. So what we would do is we would actually exchange public keys. So you can think of public keys as your bank account number. That's gonna identify where Austin's ETH is at and where I'm going to send it to. I'm going to take it out of my account and I'm going to send it to him. But in order to process that transaction between me and Austin, we have to have our private keys. And what our private keys are our proof of ownership for the things that we've actually taken place on the blockchain. So an easy way to think of your private key is when you sign a receipt. So I go charge something on my credit card, I sign the receipt to verify that this transaction actually took place. So me and Austin, we exchanged, I give him 10 ETH, we sign the transaction. We're not done yet. Now that we've decided the transaction, we've actually put it out into the ether that we want this to be written into a block. And what we have to do is we actually have to wait for that transaction to get pulled into a block and then that block to be verified. So one of the things we're going to talk about later when we get into consensus methods is how long it actually takes to commit a transaction to the blockchain. And I've got some statistics here. The number for Ethereum, I've seen all over the place, but for Bitcoin, because of the complexity of the algorithm to validate the block, it takes about 10 minutes from the time that the transaction is submitted to the time it actually gets written to the blockchain. For Ethereum, I have seen numbers as low as 13 seconds, and I've seen times as long as a day. And part of the reason for that, there is a concept out there called gas. And gas fees, think of that as the money that you would pay as a merchant to get a credit card processed. So I'm going to pay you to process this transaction. So what we can do is we can increase the amount of money, the gas fee that we will pay for the transaction, and actually get it processed soon. So that's why there is such a wide variety on times when I was digging into Ethereum. Talk about the wallet some more. One of the big misconceptions about the wallet is that your assets are stored in the wallet, and they're not. What your wallet is a gateway to the blockchain. So when you go in and you look at your balance in the wallet, what you're actually seeing is a summation of your transactions in the blockchain. And then what I have here is just a picture of Metamask showing a dummy account with some ETH in it, and then some transactions that it actually participated in. Any questions about that? Wallets.
Yeah. One of the topics you said you're not going to talk about, but it takes 10 seconds to transact the process transaction. I have 100, you're going to give you 80, and I go for some other issue. But you can take more than 80 hours.
Yeah, I could actually charge you 100 to process your transaction of 80 if you want it done.
But I'm just saying that I'm taking out more money.
Oh.
I'll start over. So if it takes 10 minutes to process a transaction,
Yeah.
what prevents me from giving you 80, giving someone else 80 at the same time or within, a few seconds? But when both of those transactions take 10 minutes to process, all of a sudden I'm now negative on my account.
So that transaction is actually still floating around out there, even though it's not committed to the blockchain.
So the second one will be rejected?
Yeah.
Okay.
Because you've got a pending transaction. Now, there's a flip side of
Darn.
There's a flip side of that, where let's say your transaction, we're exchanging 80, and we only want to pay 1 ETH for that transaction. Well, nobody wants to mine that transaction. I can make more money mining these other transactions. Eventually, after a certain amount of time, that transaction just gets dropped. It no longer happens. It just falls off the face of the earth.
Because it's too small?
Because you're not paying me enough to waste my server time to go validate your transaction.
But if you provide more gas, it'll okay.
Yeah.
So it's not the size of the transaction that you and I exchange. It's the size of the fee that I'm willing to pay.
Right.
Okay.
Yeah, we'll get into it a little bit more when we get into consensus, but it's basically a reward-based system.
Okay.
Anybody else? So what is consensus? We talked about blocks being validated before they're written to the blockchain. But how is a block validated? And that's through a consensus method. Stakeholders in the blockchain, they don't know each other, they don't trust each other. So we have to have some method in order for the group as a whole to say, yes, this is valid, this is something we want written to the blockchain. And that's called a consensus method. And there are two, so there are a bunch of consensus methods out there. There are two main that we're going to touch on this evening. One is proof of work, and the other is proof of stake. And so we're going to touch on proof of work first. So with proof of work, we have people out there called miners. And what they are trying to do is they are trying to solve a problem. So I'm going to use Bitcoin as an example. They have, so the block gets created, there is a hash out there. And what the miners are trying to do is they're trying to match this expected hash. And for Bitcoin, that hash has to start with 14 zeros. So what they're trying to do is they're trying to find a magic phrase that they can add to the data of the block, run it through the hashing method, and then get that valid code back. So there's a secret number out there that they're trying to guess. And what basically makes this a trustworthy system is the fact that I am dedicating energy and computing power to this. This is my skin in the game. So once complete, once they go through, they find this secret phrase, the block is then presented to the group as a whole. And one of the things I found interesting in researching this is everybody stops and kind of huddles around and says, yes, this block that you've submitted, you've actually found the correct phrase for this. And it's at this point that the block is accepted, it's written to the chain, and then I'm going to give you some portion of the transaction fee or the gas fee as a reward for you committing your computing time and your energy into solving this hash. Now, proof of work, if the validation fails, or for some reason I present an invalid block, I've tampered with it, the transactions in it, and I present this out there, and the consensus is that this is a bad block. The worst thing that can happen to me in proof of work is my node can get banned. And when we talk about proof of stake, we will talk about how there's a little more skin in the game than just getting banned. And because with proof of work, there's nothing to stop me from going and setting up another miner node somewhere else under a different IP address and coming back and trying to be a bad actor again. Excuse me a second. So the pros of proof of work, security. So we're going to be talking about a 51% attack, and it's going to be different with proof of work than proof of stake. So in proof of work, in order to write fraudulent transactions to the blockchain, I would have to own 51% of the computing power in the network. That way I have the majority of the nodes and I can create false consensus. So when a coin is at scale, like Bitcoin or Ethereum, it's going to be very hard to gain 51% of the power, the consensus power, computing power. So that's considered a security pro. Some of the cons of proof of work, and this is the one that you hear about the most, is resource consumption. Proof of work uses a ton of energy, and it ties up a ton of computing power. And the argument is that these resources could be used for other things in society than solving a cryptographic puzzle for a coin that just exists out in the ether. The other thing, and we touched on it before when we talked about Bitcoin taking 10 minutes to validate a block. They have a scalability issue with proof of work. So we've created this really complex problem where they have to sit there and basically randomly try things to get to this hash with 14 zeros. And that takes time. So we know we've got a time constraint on actually validating the block. And then there's a fixed number of transactions that make up the block. And it varies by blockchain, but there's, might be 1,000 transactions in a block. So we've got two hard constraints on how much data we can actually write to the blockchain. So one of the problems that Bitcoin is going to run into eventually is that they cannot process transactions to meet demand. So then we're going to talk about the other side of the coin, which is proof of stake. And with proof of stake, what we've done is we've simplified what you need to do to validate the block. There's still some sort of, work that you have to do for proof of stake, but the emphasis has changed from you putting computing power in there and that being your stake to you actually have to put in coin. So in the case of Ethereum, I actually have to say, okay, I will stake 25 Ethereum. And if I do not fulfill my role as a validator, you can take my stake. So I'm actually putting money up to say that I will be a legitimate validator. And that process of putting money up is called staking. So validating a hash or a problem is still there. Like I said, the complexity is reduced. When the block is accepted, the validator is still paid from the gas fees. So that's their reward for staking their money. If the block is rejected, unlike proof of work, where you're going to ban me, I'll come back somewhere else. I'm actually going to lose my stake, and that's called slashing. So you're just going to just take my coin from me. So the pros of proof of stake are that there is actually a hard penalty out there. There's more than just getting banned. And then the other one, of course, is there's less work. It's a less complex problem. So I'm going to hit on the last con, and then I'm going to circle back to the Ethereum merge, because I'm sure that's, when you talk about proof of stake, you're almost obligated to talk about the Ethereum merge. So the last problem, the big problem with a proof of stake system is we still have a 51% attack. Instead of 51% of the computing power, in this case, you have to have 51% of the coin. And what this allows you to do is be the biggest stakeholder or be multiple stakeholders. And then once again, you can create false consensus. One of the reasons Ethereum did not start off with a proof of stake model, they started off with proof of work, was actually to prevent someone from obtaining 51% of the coin and having that power. So through the research that I've done, the recommendation is to start off proof of work, build and get acceptance, and then once you hit a critical point, switch to proof of stake. So I'm going to talk about the Ethereum merge, which just happened recently. So that was the Ethereum blockchain actually switched their consensus method from proof of work to proof of stake for the very reason that we talked about. It was highly energy consumptive. So they are trying to position themselves as the environmentally friendly blockchain. And the reduction I've heard is anywhere between 95% to 99% reduction in energy consumption. So what you may be thinking, though, is how did they pull this transition off? And that it's actually hidden in the name. What they did is they actually stood up another blockchain. They forked the blockchain. They created a blockchain called Beacon. And they actually ran proof of stake for a year and a half to prove it out and to validate that when this thing went into production, it wasn't going to blow up. So when we talk about the merge is actually the Ethereum mainnet coming together with this Beacon blockchain and then them unifying. And when this unification occurred, the old proof of work nodes stood down, the new proof of stake nodes stood up. And they were able to pull this off without stopping the blockchain, which is very impressive. They did not stop processing transactions while this occurred. Yeah.
You go back to the last slide for me.
Yeah, sure.
I still don't understand why the hash is easier to figure out and why you get so much reduction in energy consumption.
So it's not, so before I was making it, we'll get into hashing and why that's a completely arbitrary system, but I'm not so much guessing anymore of what it is. I actually, so the trust before was that you're spending all of this computing power to figure this problem out. So you're gonna do a correct job because you've dedicated all these resources. So what we've done is we've flipped it, and you're just validating that the transactions in the block and the hash come out good. So there's no guessing anymore. Because you've put money on the line, that is why I trust you. So there's no complex me sitting there generating random phrases, sticking it into the block, rehashing it, trying to figure out what that magic phrase is that generates that magic hash code. I'm going to trust you to do the work to make sure that the transactions in the block and the hash come out correctly instead of just randomly throwing stuff at it.
So I don't have to guess what the transaction is to finish the block. You're going to tell me what the transaction is,
Yeah.
and I'll finish the block and see whether we got the same answer.
Yeah.
Okay. Okay. So you trust me with the transaction information because I am making a mistake.
You're right.
Okay,
Because I'm
okay.
going to take your money away from you if I find out you lied.
Okay.
Yeah.
Stop carrying off time.
Mhm.
It's all eventually.
So you stop caring about the length of time it takes to solve the hash because there's real money on the line.
Right.
So it'll still get solved, but if it doesn't validate out, you lose your money.
You lose your money. So,
Yeah.
and that goes back to where if a bad actor had 51% of the coin, they would be the highest stakers, and you could forge a block into the champion. Anybody? Yeah.
Whenever the slashing happens,
Mhm.
Hello. Yeah. Whenever the slashing happens, what happens to the coin? Do they go back to the network to distribute, or are they going to a dead wallet?
They're going into a dead space. There's a
Oh.
concept of burning coin.
Yeah.
And
Yep.
yeah, and that's
So
what
all of them
happens.
are.
Yeah, it's gone.
Also, in proof of work, you said they huddle together and kind of share the hash. Does that happen in like a broadcasting way? Because there's no centralized way to
Right.
control it, right?
So there's layers in the nodes. There is the concept of an engine, and that coordinates the communication between the nodes.
Okay.
There's an execution layer, which is actually putting the block together. And then there's a consensus layer, which is actually validating the block out. And if you do research into the new model in for Ethereum with proof of stake, they, instead of that being all one piece of software, there are now execution clients and consensus clients.
So it's like a command and control for the nodes. engines work in.
Yeah.
Okay.
Yeah. So I come up and I say, hey, I solved it. Then everybody stops working on that problem with that block. And then we get together and basically check my work, make sure that I'm right.
Thanks.
Yeah. Cool. Anybody else? Kevin? Oh, cool. So yeah, I couldn't find a good graphic for hashing salmon and hash browns. Seemed the most appropriate. Waffle House afterward. So so like I alluded to before, a hash is a result of a function that takes a variable amount of data. And I mean, you could throw the Encyclopedia Britannica into this thing, and you would still get a fixed width key back out that is completely unique to the data that we put in. So there are 4 characteristics of a hash function. The first is that it is impossible to get the same hash for 2 distinct inputs. So I had a discussion with somebody, I think it was Dale earlier. We were talking about the possibilities of a collision. And what that would be is if I could put 2 different inputs into a function and get the same hash out. So I could forge a block that way. So the other characteristic is you always get the same output for the same input. So that's what allows us to validate the block. And then I've said this a million times at this point, no matter how much data goes in, you get a fixed amount back out. And then this is probably the most key principle, is changing the input slightly drastically changes the output. And going back to what we were talking about before, we're trying to solve the problem of what can I add to the block that creates this hash. So if I put in, so say I have, 1, 2, 3 is my data, and I shove that into the hashing function and I get ABC back out. If I change it and I put 1, 2, 3, 4 in there, I'm going to get YZX back out. So there's no correlation between the input going in and the output that's generated. So I can't sit there and manipulate the input coming into this to try to guess what the output's going to be of the hashing function. So just to touch on why this is called cryptographic hashing, all of the math, I'm not going to go into cryptography, we'd be here all night, but the math behind how these functions work actually came from cryptography, where it's vital that I be able to check the data integrity of a message that got back in. 2 takeaways from the slide if you don't remember anything else. Hashing is not encryption. So with encryption, I could take the value coming back out, I could run that through a function, and I actually get the data coming back in. That is not how hashing works. You cannot take the hash and figure out what the original data was. The second thing is the algorithm that's used in most cases for hashing. And that is SHA-256. It's been around for a really long time. I put in bold here that it's not known. There's no 2 known inputs that can create the same output. But it has been battle tested and it hasn't happened yet. For those who are familiar, earlier there was an algorithm called MD5, and it was thought to also be a solid hashing algorithm, and it's still used in some places for password hashing. It is considered a broken algorithm at this point because they have found multiple inputs that generate the same output. So it would not stand the test for what we want to do with blockchain. So earlier, I kept talking about this magic phrase that we add to the block to generate this hash. And this magic phrase actually has a name. And it's called a nonce. And the nonce is simply a number that's used once. So in Bitcoin's implementation of proof of work, like I said, I've got 18 zeros here. We need a ton of zeros. But what the miners are trying to do is they're actually trying to randomly generate this nonce. So part of the reason you hear about GPUs being used for mining is because they are really fast at generating random numbers. So basically what we're doing is, because I can't look at the output from the previous input I put in and guess where I need to go, all I have to do is sit there and push values into this as fast as I can. And that's part of the reason proof of work is so energy intensive, is because I just have to guess. So as we've discussed before, once that correct nonce is found and it generates the desired hash, the block gets presented to the blockchain and is validated and written. So in the previous slide, we talked about a slight change to the input of a hash causing the output to dramatically change. So what this does is this gives us an interconnectedness. So because each block contains the hash from the previous block, if we changed a block, rehashed it, put it back into the blockchain, it would immediately become evident that that block was incorrect, because the hash validation would fail on the blocks going forward, because I've tampered with this guy. He now has a new hash, but that's not what was saved in the block in front of this. So when we talk about it being tamper evident, that's what we mean. So if we wanted to actually, game the system and try to push a block out there that was invalid, we would either need to find another set of inputs to go into our hashing function that gave us our desired output and met the original hashing, the original hash on the block. And we've said with SHA-256 that that's just not a possibility. Or we could rehash our modified block, and then we rehash every block in front of it, which is time intensive, but we could forge a new version of the blockchain. The problem with that is I am now the only node that has this blockchain. This is called a fork. So I'm now the only person who has a copy of this blockchain. I have to get somebody else to buy into it to get it to distribute out. And that's when our consensus method comes back into play. So in order for me to take my new copy of the blockchain and get it accepted as truth, I either have to have 51% of the computing power or 51% of the coin to get a consensus to have this guy written back out.
Going in. I'll just hold it. So a nonce is a transaction, an individual transaction.
No, a nonce is, so I got my block out there, and what the nonce is just some data I'm throwing into the block. So the hash is generated off the contents of all the transactions, all that data.
How many transactions in one block?
So there could be, I think for Bitcoin, I think it's 1,000.
1,000.
Yeah.
So if I wanted to hash the current block that we're on,
Mhm.
I would start with the hash from the last block,
Mhm.
and then take the 1,000 transactions and hash those 1,001 together
Yeah,
to get a new hash for that block.
right.
What does each transaction look like?
It could be as simple as, so you're going to have a to wallet, a from wallet. So you're going to have the addresses, those public keys.
Okay.
and then you're going to have what occurred. And that could vary depending on whether it's a smart contract contents or whatever, but it's going to be, I gave this wallet address 20 Ether. So
What is it? Is that clear text to me as a miner, as a validator?
I do not know, actually.
Okay.
Yes, it is, because if you remember when we went back, so for those of you who don't know, we did a blockchain training, and one of those actually used a tool to go out and search the smart contracts
Mhm.
on the blockchain, and all of the data about the transaction was there in plain text.
So what am I trying to guess? If I'm trying to
So-
figure out the current block hash will be, do I have to wait for 1,000 transactions and then hash it all?
Yeah, so you don't start hashing until you get to a block.
Okay.
Okay, so what's happened is the system has stuck a little something extra into that block.
Oh, the
That's-
special sauce.
Yeah, so that's your nonce.
Okay.
And so I tell you, hey, I expect, the hash to be blah, 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 14 zeros. And what you're trying to do is trying to guess what that secret sauce was that I put in there that made that come out that way.
Gotcha.
And so that's when you're mining, that's what you're trying to do. You're trying to guess what that secret sauce is. And
Okay.
then once you figure it out, then that's when you present your work up to the network to have it accepted.
And what happens if a blockchain is loosely transacted so that 1,000 transactions take a couple of days to actually collect? Like Kingsman coin,
Oh,
like
yeah.
there's not thousands of transactions happening every second.
Yeah. So if you were in a situation like that, I would lower. the-
Okay, you can lower. Okay,
Yeah.
okay.
Yeah. So the number of transactions going to block varies by blockchain. So the way we had Kingsman coin set up, it actually one transaction created a block. Yeah. Anybody else have any questions? Oops, went too far. So let's talk about smart contracts. Smart contracts are actually pretty cool. This is some code that we can write, that we can put out on the blockchain. And like their paper counterparts, they contain a set of terms and conditions that have to be met for this thing to execute. And those things have to be agreed upon by two parties. Unlike a paper contract, it's registered on the blockchain. So I don't have to trust, go into Kevin's office, pull open the filing cabinet and go with the contract. It's just out there publicly. So anybody can see the contract and what the contract does. So there's transparency involved. Other thing that's cool about a contract is it can execute autonomously. So we can set the contract to say, hey, when Ethereum reaches X price, go trade, with some basic attention token, something like that. So we can actually have triggers that occur, either events with cryptocurrency, or there's the concept of an oracle, and all an oracle is a data source from outside the blockchain that feeds data into the smart contract. But we can actually set our smart contract up so that it executes when conditions are met. And an example of this that I've seen several places is if you think of a smart contract for insurance. So you as a farmer, you take out insurance with me against a drought. So we can write up a smart contract that says, okay, if you have 10 days of temperatures over 100 degrees, this smart contract automatically pays out whatever the amount is. So smart contracts are the major driver in a system called DeFi, or decentralized finance. Because instead of just exchanging coin between wallets, we can now apply logic and we can start to create complex financial instruments. So this has allowed blockchains to actually challenge traditional financial institutions. So you can go out on the blockchain, you can take out a loan, you can actually stake money for that loan and get paid interest. And we can do things like security trading. And like I mentioned before, we can actually trade coin across exchanges. So the things to take away from this slide is not all blockchains support smart contracts. Can't go write smart contracts on the Bitcoin network. Four of the most popular are Ethereum, Terra, Avalanche, and Solana. So the concept of a smart contract leads us into the next thing, which is a dApp, or a decentralized application. And that is just a set of interconnected smart contracts that together create some functionality. And with Web3, we can tie, our React front end or our website in to interact with the smart contracts. So it can be any mix of traditional web stuff and the smart contracts. We've got our smart contracts in there somewhere. And then the next thing is a DEX, or a decentralized exchange. This is a specialized type of dApp that allows for trading of securities without an intermediary. So I don't need a broker. I don't need my Fidelity or whoever to go in and facilitate a trade. It's literally between the buyer and the seller. So we'll touch on tokens. I'm not going any depth into NFTs, but there are four types of tokens we want to go over. So a token is just an asset stored on the blockchain. And under this definition, a coin is actually a token. So the types of tokens we're going to talk about, one is a DeFi token. And DeFi systems that reproduce traditional financial systems, they issue tokens that can hold financial value. So like we did with the Kingsman coin, we paid interest in a token. And then, that token could have value and it could be traded on exchange. The other thing that that token could also do, so instead of me paying you back in interest in some financial way, I can actually give you governance on the platform. So that leads into the next type of token, which is governance token. And what a governance token does is it gives the holders say in the decentralized application. So you realize we're out there, we're this node of people. We still need a consensus method to set the direction of the application. What features are we going to do to the dApp? Where are we going to take it? What are we going to do with the exchange? So governance tokens are issued and they basically give you voting rights. Then we get into NFTs, which are fungi. So NFTs represent ownership rights to a unique asset. That's all an NFT does. And that's where the non-fungible bit comes in. An NFT has to be something that can't be exchanged for something exactly like it. So the real world example that I always use for a non-fungible token is a NFT that represents a ticket to a concert. So that's for a particular row and a seat. And I can't exchange my ticket with your ticket and have the same experience. The seats are different. Whereas if I owe you $1 and I give you 4 quarters, that's an equivalent exchange. The last thing is a security token. And a security token is a new class of assets that aim to be the crypto equivalent of a traditional security like a stock or a bond. The main use case is to sell shares in a company or enterprises. So right now, if I have a business and I need to raise a bunch of capital, I would go out and I'd do an IPO. The equivalent of that in the blockchain is an initial coin offering. I will go mint a token and I will, for your Ether, your Bitcoin or whatever, I will take that in and I will give you security tokens back in this great business that I'm about to create. So it's the equivalent of having stock ownership in a company. So the difference between, so a governance token just lets you have voting rights. Security token lets you have ownership. So before we get to the last section, does anybody have any questions?
I think it is. Like wall that.
At least you're not going to socks. Get the bear off the stage. Cool. So we'll talk about some cool uses of the blockchain. So for me, cryptocurrency is not where it's at with the blockchain. It's the actual idea of this interconnected ledger that is self-verifying. That is where I find this really interesting. So we've got 4 examples here to close this out of ways different companies are using blockchain technology. And I think the first one is really cool. Sweden's Land Agency, and bonus points to anybody who can pronounce the name, is conducting a trial where they are moving their title registry from paper actually onto the blockchain. And they're trying to reduce the cost that in manpower it takes to register the deed. And they are eliminating barriers like the need for title insurance. I don't have to worry about somebody showing up and saying, hey, they already have a title to this thing. It's all verifiable on the blockchain. So I think that's probably my favorite use of blockchain. I did some research, some digging into it. I cannot find if they're actually doing this on a private blockchain that the government is sponsoring and is publicly available, or if they actually execute this on a public blockchain. I suspect it's a private blockchain the government runs that's publicly available. The next really cool thing is the concept of a digital healthcare record. So part of healthcare records going electronic was supposed to make them more portable. So there are multiple companies out there that are trying to solve this problem of patient data portability by building systems that put the patient's healthcare data onto the blockchain. And most of these models work by the patient data, the PHI, being encrypted with the patient's private key from their wallet. And what that does is that makes the patient the only person that can access that data. And that puts you in control as the patient with who you want to share this data with. So my third example is one that you traditionally think of is customer rewards. So Fiat Chrysler and a UK startup they have a program going where they're trying to promote more efficient driving habits. So what they've done is with the Fiat 500 electric, it has driving monitoring capabilities, and that data gets written out to the blockchain. And what they do is they actually take that data and determine how you rate as a sustainable driver. And they issue what they call Kiri coin, which is just a token that they've made up. But that token is then redeemable from services from Fiat. So they're actually using your behavior to drive issuing a token to try to make you drive better, which is pretty cool. And this last one is interesting. And I was actually surprised to see that Verizon was using it for press releases. It seems like a use case that would fit more generally out in the media. But there's the concept of a trusted source. So Verizon has launched a system called Full Transparency. And what they are doing is they are publishing all of their press releases and their press release updates onto the blockchain. So there's now a single truth of source for what the company said. So this evades the fake Twitter account tweeting on behalf of Verizon, whatever. We can go verify what Verizon said against the blockchain. So what they're trying to do, of course, is they're trying to gain consumer trust. You can trust what we say. We've got it over here. And they're trying to raise corporate credibility through this program. So those were the what I thought were the 4 coolest examples of blockchain technology outside of cryptocurrency. Does anybody have any questions? You're welcome.
On the back one slide on the actually leave it here, but we talked about NFTs and NFTs being used for concert tickets.
Yeah.
Are those being used today for Charlotte football? I mean the soccer team?
They're not blockchain based, but like through Ticketmaster or whoever I buy the ticket actually goes into my Apple Wallet. So I don't have physical tickets anymore. They're not stored on the blockchain, but the concept of electronic ticket is taken off.
Right, but it used to be you could take a screenshot of your ticket, which effectively has a QR code, right? Or which is a fancy UPC code, barcode. You used to be able to take a picture of that, and like if I bought 2 tickets and you're bringing to the game, but we're gonna arrive at different times, I could take a screenshot, and send that to you. But these days you can't take a screenshot. You actually have to go into Ticketmaster, and I have to transfer that to you. Is that blockchain or is that just other technology?
Ticketmaster.
Oh,
There are places that are working on this. Ticketmaster is not one of them.
okay.
But so what they've done is they've implemented the idea. There's just no blockchain.
Okay.
So what we would do if we were doing that on the blockchain, we would actually go into our wallets, and you would say that you wanted to transfer a ticket to me. You put in my public address. Thing would pop up in my wallet. It says, "Hey, do I want to accept this ticket from Kevin?" I would say yes, and then I would have that.
Okay. What? Oh.
Relinquish the microphone. So I have a challenge with this trusted source. I think that our next Kingsman Apprentice project should be media transparency. And so we have one single source of truth for what politicians say and what anybody says in the media. Frank? On it? Done? Okay, awesome. That's all.
Yeah, like I said, I was surprised Verizon was the only place that had this idea. I mean, this actually seems like it has applications for wider media and for public officials and stuff.
I would say I would probably think that Sabrina is going to have some black helicopters outside her house later tonight.
Cool. All right, anybody else? Yeah.
All of these different use cases, do the companies need to create their own coin, or are they able to build it on top of other coins, or how does that work? Like for the land titles?
So what happens is basically the smart contract that would contain that transaction that I bought a piece of land from you. So it has an address on it, just like a coin would. So it just gets stored out there as an entity on the blockchain. So there's not necessarily, you could create the concept of a token that represented that property if you wanted to on top of that blockchain. But the smart contract itself, when it executes, it has all of the data between the transaction between me and you.
I think I'm asking more.
It depends on what they're trying to accomplish. Yes, so he was asking if everybody had to create their own token. And it depends on what you're trying to do. So if I had some scenario where I wanted to give ownership or governance or something like that, or where I wanted to, let's take an example of Funko Pop, where they went out and they created their own tokens. And if you collected this set of NFTs, then you could trade them in for a physical Funko Pop. So my answer is going to be yes, that generally that they would have to create their own token, but it would really depend on what they're trying to do.
Rick, can I add to that? So like blockchain,
Mhm.
if I want to go create a token on blockchain, I cannot do that, right? Because blockchain is only for blockchain. Sorry, Bitcoin. If I want to create a new token on the Bitcoin blockchain, I could not,
You could not.
because that is only for Bitcoin. But Ethereum allows you to put your own token on the Ethereum blockchain. So you're basically leveraging someone else's rails.
Right.
So that's when we built Kingsman Coin, and like we had what 40 of us go build Kingsman Coin. There's 40 Kingsman coins out there, 40 different types of Kingsman Coin, all on the Ethereum blockchain. And so in theory, if the Swedish land
Registry.
agency,
Yeah.
whatever that name is, Land Marriott,
Yes. Tech support.
if they wanted to use Ethereum, they could. And in that single use case, you might use an Ethereum. But if you were to be the SEC and you wanted to take all the current shares that are so all the public companies that are out there on the New York Stock Exchange and the NASDAQ, and you wanted to tokenize those, you might not want to use Ethereum. That might be a use case where you can go build your own blockchain using your own algorithms, because it's a big enough use case.
And if anybody's interested in spinning up their own blockchain, AWS actually has a service that'll let you pick. I know it does Ethereum, it does a couple other blockchain types. It is the only pay-as-you-go service that I'm aware of that'll let you spin up a blockchain up there. Azure used to have it. They have shifted that responsibility off to another third party. Anybody else?